Okay, so welcome to my talk. If I get enough questions, I'll explain the story about the fez, and the best question gets a brain teaser of my own collection. Okay, so pleased to meet you. My name is Ange Albertini, and I'm the author of a website which is about reverse engineering and visual documentations. And really, I'm not an exploiter, I'm not a fuzzer, but I'm just someone who likes to play with Legos. I mean, like making stuff with low-level Legos, such as this. And basically, one of my hobbies is making binary files from scratch by hand, entirely the whole structure. This enables me to actually, control the whole structure, because sometimes there is something weird in a file, but actually there's another bit somewhere that defines it. And by remaking the property I want to study, I'm able to actually make sure this is how it works. And then this file itself is clean, even though it's weird for some reason. And then I share all those files, and all the materials you see there is shared on Corkami, on my website Corkami. And in the end, for example, here I created a full, complete binary file. So this is a complete Windows executable files, also available in Legos, yet harder to execute. But this is really what I create, complete files from scratch, and that then are executable in a normal way, but are extremely clear to read, even the complete entire binary structure. So today, the problem is related to virus, and most importantly, the binary formats used in virus. So typically, one standard infection chain is, for example, you visit a website, which is a web page in HTML, and then it embeds a Java class, which has an exploit in it, and then it makes you download remotely a Windows executable that gets on your machine. So a standard chain of execution involves three formats in this case, or another standard execution chain, infection chain for a malware is a PDF that will exploit Adobe Reader, and then you get, once again, a malicious PE files, portable executable binary on your hard disk. So the problem is obvious. For any security tool, it's important to accurately identify the file format of a binary of any files that comes in, and then it's also critical to determine whether this file is corrupted or not clean, but correctly formed or executable, and then it would have actually to analyze it to tell if it's malicious or clean. But it's really important to tell if it's corrupted or not. And sadly, in most of the formats, it's really easy because you have a magic signature in the first bytes, but you have some formats, for example, like command file or MBR, which have absolutely no header at all. Then you have some formats, like typically the archives, that don't require their header to start at any part of the file. And then you have some formats, like the PE file or the Macintosh pict, which enable the possibility to have a huge blob of data near the signature. So there is a signature, but it's not, then you have plenty of space to play with. So it actually came through a true story I had at work, and we had an HTML file that was just had the first byte set to MZ, which is a signature of a PE file, and suddenly the engine thought, oh, this is a Windows executable, let's analyze it. And of course it said, hey, this is highly corrupted. Only MZ signature is present, so then it gave up scanning it, and of course it wouldn't even tell if the file was clean or malicious because it was going in the wrong direction. So let's first, messing with binaries already have some example in the wild in 2008 as the form of GIFR. So it's a mix, it was a GIF. So people would upload their avatar on a forum, and it was as a GIF file, and then appended to this file, you would have a class, and this Java class would actually contain an exploit. So basically, it's hosted by the server, and this gives the attacker, they already uploaded an exploit on the server, so you bypass cross-domain policies. So basically, here I made an example that is available like the other ones on my site. And this file is if you load it as a source, it's an image, and if you load it from an applet perspective, then you have something extremely malicious happening on your computer. Oh, sorry, it's not displaying, yeah. Completely evil, as you can see. So that was actually a real example of messing with binary format that happened in the wild in 2008. So now let's start with exploring a bit the Windows executable format, the PE file format. because, first of all, most infection on Windows eventually end up with having a binary on the disk, downloaded at some point. It's possible to do without, but really most of the time that's the case. And the PE file format is made of a lot of structures put together, but most importantly, the headers is it's a sandwich of a historical header that came from MS-DOS in 1981, and then they added another modern headers that is linked by the first one, and this one was added in Windows NT. So the thing is, in the DOS header, now all the elements are completely useless, except the last element, which points to the new header, the new modern header. So this is useless. It just needs the MZ signature and the pointer to the next stuff. And then the next header, you can actually put it anywhere in the file. And of course, I made a proof of concept where here, the header is actually at the bottom of the file. So it's a PE footer in this case. This is a file that I call standard test, core chemist standard test, which gathers all the x86 oddities and the PE oddities I could think at the time. And this is one of the characteristics of standard test. It has a corrupted, the PE header is actually a footer. So HTML, sadly, not much is enforced at this case. So basically, you can just put an HTML tag anywhere in the file. So here, for example, I created a file that was 27 megabytes of appended to a PE file, and still it opens correctly as a Java file. So the problem is, so you can have anything, and then eventually you have your opening HTML tag, and then the page is correctly handled by the browser. Sadly, there's even the same result since Mozilla 1.0, as Nicolas Grégoire helped me to test. So even the same result was working the same way in Mozilla 1.0 long ago. From a PDF perspective, it's important to determine where the signature is, and sadly, Adobe is not exactly clear with that. So basically, they say that the header, can you read? The header consisting of 5 characters at the beginning, but on the other hand, they say that Acrobat viewers themselves, they allow it within the first 1024 bytes. So basically, the specification said it should start with the signature, but then they say our viewers actually accept it after that. So even from their own official documents, it's not already clear. So basically what you can do is first you can append a small PDF after, you can append any PDF after a small PE files. So here the PE file is executing correctly, and it's also valid as a PDF. And oops, sorry. And then if you trick it a bit further, and if you immediately start the PDF with a fake object, with a fake binary object, and then you put the PE file entirely, and then after the end of the PE file, you resume the PDF by closing the fake object, then you can put really any document in your merge with the PE file. Java file, sadly, there are not many problems because you can put Java files in a zip. Then it becomes a Java archive, jar, and then there are not many restrictions because the zip could be anywhere in the file. The only restriction is Java itself doesn't like that there is a single extra byte appended to the Java file, to the jar file. That's not really a problem, but it would be too easy if it was respecting things, but because it actually doesn't, it completely ignores the CRC. So here you see I made the file by hand and put completely fake CRCs, and of course you should get the bad CRCs, but Java doesn't care and it works perfectly. So that's CRCs were used to check if the file was corrupted or correct, but here it's ignored. Okay, thank you. So then you can actually merge all those formats together. So to summarize, you actually have to start with the PE signature. This is compulsory. Then you put this PDF signature and you start a fake object. Then you can put anything. Shortly after that, you actually make an HTML file. Then you just have to resume the content of the PE, which is quite strict. HTML and PDF can be anywhere within the file. And then you end up with a zip file. So I prepared a demo, but usually demos are not exactly, they are just proof of concept that are not so visual and everything. So here, I prefer making an inception demo. What is an inception demo? So basically, we're already in the demo because the slides we've been working are actually this file, and the viewer that we're using is this file. So basically, to see the slides, oops, sorry, what happened? So to see the slides, I have to run the file on itself, and the PDF will execute, and it will load itself as a PDF, and it works, because that's what we've been watching so far, right? But as I said, this is not enough. So of course, I embedded the proof of concept in a zip included in the file. And also, HTML is still there. So if you have to rename it as HTML, it's really annoying. HTML. Oops. And now, if you run it in HTML, well, we got a README HTML. And because it's boring, I added a JavaScript Mario. Okay. So that's a good proof of concept with real examples, because the slides are, I made them, and then it needed a few obstacles to be removed, but then, as you saw, it worked perfectly. The file itself is running on itself. Oh yeah, maybe you want to see the header. So as you can see, you clearly have the start, the MZ signature of the P, then the HTML comment, the PDF signature, the fake object, and then the rest of the P file, and so on. Okay. So let's resume. Yep. So, okay, so this is a real example, but this is interesting and funny, but not really useful for people to make their parsers stronger. I mean, I like to play with these things, so I would go further. And typically, I wanted to harden all the aspects of such a proof of concept. And if you know me, then I start to add more features to make it quite, I think the booklet is referring my workshop later as for the brave or the twisted. So let's say I made a proof of concept for the brave and the twisted. So PE-wise, I didn't go too crazy, but still you can actually do some weird stuff. So for example, this is, can you see the pointer actually, or it's better with the mouse cursor? Which one is better? No, the pointer is okay? Oops, sorry. So typically, as I showed with the Legos, I make my PE files myself. So a normal header, PE header is like this, and I typically make them without much fewer elements. So for example, I played with the import structure of the PE file, and import structure is typically made of one list of descriptor that each of them point to two lists of thunks, and then it builds together the import table. So this should be the descriptor, and then the two lists should be independent. Of course, you can make all of them together in the same structure pointing to each other, and this gets a funny result. IDA didn't like it, nor Hugh. So at the time, it was breaking all the parsers and all the tools because they didn't think the table was valid at all. Also, I wanted to add some undocumented opcodes. So if you look at Intel documentation, you have big spaces of white. But if you look in the AMD documentation, suddenly you have some information about this opcodes. And then if you actually implement this opcode yourself, so that's prefetch and nop from group P, if you actually implement these opcodes yourself, the CPU has no problem executing it, but WinDBG, who follows the Intel documentation perfectly, doesn't see anything. So this could also fail your dynamic emulator. For PDF-wise, I went a bit crazy, because the first problem is that there is a specification which is more or less fuzzy in here, and then you have the problem of the actual implementation. And here you can make here a file that works perfectly in Sumatra, and Sumatra is based on UPDF, which is used in Linux viewers. So basically, you could say that's Linux viewers. So the file works fine in Sumatra, but is failing under Chrome and Adobe Reader. Then you can make a file that works fine under Adobe and fails under the other two, and so on. So first, the standard is everybody has their own interpretation, and let's see that in details. So these three files are likely doing the same thing, but here I highlighted the differences between each of them. And it starts getting really crazy. Oh, what did I do? Oh, I closed it. Sorry for that. So here, the worst thing that you see is that there is no PDF signature. And actually, that's true. Linux viewers and Sumatra and other based viewers like Evans, they don't even require the PDF signature to be present in a PDF. So you see the hell that is coming from? Any other parsers will say, this is not a PDF, but if you specifically wanted to exploit someone via PDF on Linux, on Sumatra, perfect. It will never be identified as a correct PDF. And then you have some other oddities. So for example, here, you don't have a trailer keyword. Here, in the case of Adobe, actually, Adobe is much more sane than Chrome or Sumatra. In Chrome, you can have the trailer in a comment. That's fine. And it even overflows the object reference. So these huge numbers are actually referencing 21.0. So compared to that, suddenly Adobe is really sane because Chrome and Sumatra and the Linux viewers are really crazy. And another example that was highlighted by Jonas Magazinius was a crazy object where the specifications say that streams must be indirect objects. So basically, whenever you refer a stream, which is any kind of data in PDF, it should be in an independent object, not inlined. And here, sadly, this is absolutely not the case. And if you see, even the brackets, they are not closed. And we don't even have a trailer. We only have one object, which is referencing itself. So this file is completely corrupted. Like the brackets are not closed, the streams are inlined, there is only a single object, there is no trailer, but it works fine. No warning at all. And here it's actually important because the stars are actually required, even if they are in comment. So you need a certain amount of bytes so the file is accepted. Why? I'm not sure why, but that's pretty crazy. And if you really wanted to parse a PDF accurately, good luck. Another example the other way is the PDF.js that is now embedded in Firefox is actually way too strict. And to make a document that is working under PDF.js, I had to actually add some elements that are typically ignored by other parsers because they can be corrupted. So basically, it's too strict and it's actually really difficult to make by hand a PDF for them. So I don't want to be their QA because some tools create really corrupted like PDFs that are accepted by other readers, but PDF.js will reject. So in the end, I actually went further, and this is the same single file that is, actually it's not a single file, it's 3 PDF documents that are merged in the same file, and each of the viewer is actually seeing a completely different document. So it's time for alternate reality demo. If I take my document again, and I open it in Chrome, what do you think will happen? So the same PDF, as you saw the slides until now, and now this is a completely different document. It's not a cheat on a conditional value. It's like Chrome just sees another entirely different PDF document. This is still the same file with the PDF, the PE, the Java, the proof of concept, and the other PDF of the slides that you saw until now. So let's resume the presentation. So in the end, I made a proof of concept that I call CoreCamix, which is by hand a file containing all those formats with all those tricks I included and mentioned. And because I completely control the whole structure of it, I could also add some extra fun. So for example, a part of the HTML file is within the PDF document and so on. I think a part of the PDF is actually within the Java class, which is inside the zip, because I could just I made all those files manually, and then I could just interleave them together, and it all works fine. The thing is, so it works in all the formats, P, PDF, Java, etc. The thing is, Adobe added an extra check since, and now they don't respect their own specs anymore because they reject PDF that start with the magic, like the P magic value. So before CoreCamix were working fine, and now it returns an error. But it's funny because it's not even in their own spec. But at least it's a good progress regarding security. And then I went, not just Windows, I did the same thing for Linux, so ELF and PDF. And because of the properties of the ELF PDF, of the Linux PDF viewers that we saw earlier, the PDF actually has no signature in this case, which means even though it works correctly under Linux-based viewers, library viewers, it's completely failing under Chrome or the Adobe Reader because it's absent on the signature is absent, and the Windows viewer typically need it. And then I went further, and I did also a Mac OS, so a Mac OS file that has a PDF, Java, and so on. The funny thing in this case is that I don't have a Mac. So I made the file blindly, hoping that it worked, and Nicolas Serio actually tested it for me, and it worked at the first time, so I was happy. I created a Mac OS blindly without a compiler. Just a normal day for me. Okay, so what are the consequences of that? The consequences of that are the security tools, they are just compared like washing powders. It means they are just compared how fast does it take to detect this amount of file, and for each binary, there's a Boolean, is it clean or malicious? We, as the public, doesn't care about the result. One binary should be clean or malicious, and it doesn't really matter how it's launched, how it's seen. And the problem is that basically, these fakes, all the engines have to cheat for speed reasons. And the first problem is that to create confusion in the engine. So basically, the engine will start thinking it's a P instead of HTML file. Or you have this, and VirusTotal, you upload my P files, and then it says this is a PDF. Or the other problem is that the engine basically cannot waste too much time on a single file. And then it will cancel its scanning cycle if it takes too long on a file for performance reason, so that it succeeds in the test of PC Magazine or whatever. And this is actually what is exactly happening with me with this file, because basically this file that is a double PDF, zip, HTML with JavaScript, if I open it, it takes, the computer is completely stuck for like 20 seconds because of antivirus, so I added an exclusion on my antivirus so that it works. So this file is a real example. Don't worry if you want to see the slides afterward. I also will distribute them in a clean version, normal, without everything. Because your antivirus, your IPS might not like it or crash or anything. And yeah, of course, I didn't mention it, but CoreCamix created a lot of crashes, bugs. Yeah, 2 antivirus crashed, Kaspersky Gateway crashed, bugs in Hue, OLEDbug, IDA, because of the P, because of the disassembly. Yeah, I had plenty of fun. So the problem of that is that, as highlighted by the GFAR in the beginning, you can evade filters, so you can exfiltrate data from a network, or you can defeat same origin policy, and then you can make the engine think it's clean, but actually it's not, another part of the file is malicious, or to make it tired, or to make it fake, to make it tired, to make the engine, the tool, the gateway, the appliance give up on the file, or you can actually DOS the device, exactly like I could DOS my portable by re-enabling the antivirus on it. So the conclusion is that type confusion is bad, but type confusion was created by really bad documentations. And then you have bad documentation, incomplete documentation, and then softwares have their own lazy interpretation. And as you saw with the Chrome, I really wonder what they're smoking, because no trailer, inline stream, the brackets are not even closed. What the hell? And actually, it's quite good that Adobe started to take some measures beyond their own spec by preventing the signature of PE files. So suddenly, this trick are suddenly not possible at all. I think it could be much better if the extensions should be checked more intensively. Like, as you saw, you can execute a PE file with a create process even if it has the PDF extension. It doesn't really matter. It's only in the case of HTML that the extension is actually required. So Sumatra is opening its own file as a PDF even if it's still named as an executable file. And also, I think it's really important that when you download a file, it's kind of isolated. Or maybe you downloaded it to be executed only as one kind of file. And of course, for any future file format to be implemented, it should be absolutely required to enforce the magic signature at offset 0. Some people still think it's nice to be able to put a text or maybe a ASCII portrait before a Bitcoin transaction. But I think at least for a file type sorting perspective, it's really important that future formats have their signature at 0. Do you have any questions? No brain teaser? No Fez story?
Tell us about Fez.
I know. No questions?
No, tell us about Fez.
How much time do I have? Plenty of time? Oh yeah, oh my God, I'm way too short. Sorry for that. I spoke too quickly, probably. Okay, so the story of the Fez. Why not? So it was in the Fez, I didn't own it or anything. It was, somebody had thrown it in a part of the speaker room that was unreachable. I thought it was just a box and I just wanted to reach it. I mean, I just wanted to take it down. It was obsessing me while I was relaxing. So I just wanted to take that box down in a way or another. It sounded like a possible yet difficult challenge because no one had obviously taken it down. It was really unreachable initially. So I asked a few persons for their badge holder. So you just go and can you have your badge holder? Imagine their face, to make a chain of them. So I tried to whip the Fez down, but it didn't work. So then I added my shoe at the end of it, and then it became a valid whip. Oh yeah, we had to move a table because of that, and the table was really, really heavy. I mean, it's impressive how heavy they are, but still, that was pretty easy, the easy part. Hopefully, this table was so heavy that it looked like it didn't break, even though I was whipping and jumping. And then it fell, and it wasn't a box, it was a Fez. And then someone suggested I present with it, and I got used to it. So that's the story of the Fez. We still have some time. Just usually, yeah, this is my contact information. Typically, you can, of course, contact me directly, or I'm a moderator of Reverse Engineering Stack Exchange. A bonus, because people often make reference to it. This is from Shomil Shah. Shomil Shah, I don't know how to pronounce it. Basically, it was inspired by his work, and basically you make a GIF that is also embedded some JavaScript. And the trick here is to make one of the first binary data of a GIF, a valid open comment value. So basically, this slash star is the width. So basically, this is why it makes this file that is extremely wide. So the encoded width of the file, of the image, it's a valid picture even though it's extremely small, and it makes the rest of the data being ignored as a JavaScript comment. And so you can actually reference this image as an image, and then you can use it as a script, and then you have the hello world that displays. I also made a bitmap version of it. And this afternoon, I have my workshop on PE files. If you're, so two things. First, as I said, the slides will be available in a clean format, which you may prefer. Also, I did, so a normal file. Also, I have another version of my slides, which is the same, but with much more text, so that it's easier for you to find afterwards, to reread afterwards. And for my workshop this afternoon, if you are interested, so I will speak about the PE file formats in detail if I have time. And if you're interested, you may want to download in advance the pack that I created with all the proof of concept and sources, and this PE viewer that I recommend because I asked the author specifically to make it so that we have the best PE viewer possible in a free version available for everybody. So it starts just after lunch, my workshop. Thank you for your attention.